In this video, we're going to work through 4 examples of how I go backwards, starting with a domain, like I have here, and finding a function that would give me that domain. And I'm going to take the same process that we did normally going forward and actually just go backwards with it. So I start with my domain, and I'm going to change him into a number line. If I notice here, I have everything but the number 3, so I'm missing just 3. And when I was missing just a value, that would come from a factor, in this case x minus 3, in a denominator. That was our first case of domain restrictions, was division by 0. So a function, I'm going to call it f of x, would have to have that x minus 3 in the denominator in order to get that whole at 3. Now I'm just going to stick a 1 up top, and that's going to be my function right there. Not much more to that example. Things get a little bit more complicated. Number 2. I'm going to create a number line with -4. In this case, I have cut off part of my number line. I've cut all of that off. So I know that my factor has come from some sort of square root because it cuts off part of it. So I have x, and in this case is greater than or equal to -4. And I want to go back to 0. So this becomes, if I add the 4 over, x plus 4 is greater than or equal to 0. Like I said, I know that for f of x, this comes from some sort of square root of x plus 4, and that'll get me the domain that I want. Now, I could do a 4th root, a 6th root, any of those roots. There's lots of options, and I could add other things into my function, but that's the most basic function, or a very basic function that would have a domain of -4 to infinity with an inclusive. So notice what I did there. I just took that -4 and added them back to that side to get that 0 the way I wanted it to. Example 3, a little bit more going on in this one, but if I draw a number line, it starts to shape up pretty quickly. I'm missing a value at 0, and I'm missing a value at 5/3, but I have everything else because I go to infinity there, and I go down to -infinity there. So he comes from an x, and he comes from a 3x minus 5. Both of those living in my denominator. And again, it doesn't matter what's on the top as long as it doesn't cancel anything out, and as long as it has no square root in it. So there's my function f of x. The last one here is the most complicated one. If I look at a number line, I have -4/3, an open dot, and I'm shaded that way. So if I try to write this, I can see that I have 3x plus 4 is less than 0. Now I just have to know a little bit about where these things come from. None of my domain restrictions I had were less than zeros. They were all greater than 0 or greater than or equal to. So the one way of doing this is just to think, okay, if I want to change that to a greater than sign, I have to multiply each side by -1, which would end up giving me -4 minus 3x is greater than 0. That looks more like where we came from. Or you could just mess around with the fact that since I'm shaded to the left, I have to have a negative with the 3, and therefore I need that negative with the 4 in order to make things work the way I want to. Doesn't matter. Either way, I know that this comes from a function f of x equals. Now it's a square root of -4 minus 3x, but since he's not equal to, he's strictly greater than, I'm going to put him on the bottom of a fraction. So he has to live from there. So we have to know where the location is of these different domain restrictions in order to get the type of answer we're looking for. And that's the trickiest, is realizing for this one, I have the square root on the bottom, and I have to switch the direction that I'm going in because it's coming with every value below.